Hello guys. In this video I am going to show you how to provide exclusive access to a resource, a processor chain at Mule, by using the Apache Ignite connector created by Hawkore. Specifically, using the lock scope operation. I am not building a realistic example, just a didactic one that you will be able to easily adapt when you find this use case. This example, and a few others, are published at Github. You will find the relevant links on our web page. In short, we will simulate a resource by holding the lock for 10 seconds. We will grant 5 seconds to acquire the lock with success. This way, we will be able to check 3 scenarios. Acquire a free lock. Failure to acquire the lock within 5 seconds because it is held by another process. Success to acquire a lock that is held by another process that releases it within 5 seconds. So, let's start by launching Anypoint Studio. In my case, the Apache Ignite connector is already installed. If you need to install the connector, you will find a tutorial at our web page. The first thing to do is to create a new Mule project. Go to File menu and select New followed by Mule Project. Enter Exclusive Access as project name. Choose the Mule runtime version to want to use, for example, 3.9 Community. Select Create a Maven project. And press Finish to create the project. Some Maven dependencies are only available at Hawkore's repository. So update the pom.xml file and add it. In order to use the connector you will need to create an Apache Ignite instance. So create a new file called ignite.xml. Enter an example configuration, store and close the file. Remember that you can download the full example. Find the link on our web page. Now start building the flow by inserting a HTTP inbound endpoint that you will be able to easily test later. At the property dialog, fill in the source configuration. Create a new connector configuration. Accept default configuration. Back to the property dialog, you want to produce a JSON response, so add a new header. Set content type as header name and application JSON as header value. And save the changes you've made so far. Now insert a lock scope in order to create a processor chain that will require exclusive access. Fill in operation configuration at the property dialog. First, set the lock name. This is important as it will identify the element that requires exclusive access, no matter the point of the application where it is used. Next, create a new connection manager. In order to keep it simple, change its name to Ignite. Set grid1 as instance name. And enter the name of the file that you created before and that holds the Apache Ignite configuration, ignite.xml. Also, you must define the lock you are going to use, so go to the Concurrency Control tab. And add a new lock with the same name you entered at the operation definition. You have finished configuring Connection Manager, so press OK. Back to Lock Scope property dialog, set 5 seconds as the timeout to acquire the lock. This means that if the lock cannot be acquired within 5 seconds, an exception will be thrown and flow execution will be interrupted. Now insert an expression processor inside the lock scope. This processor's function is holding the lock for 10 seconds. Enter a meaningful display name. And enter the wait sentence. Use the thread sleep method to make it stop for 10 seconds before continuing. Save the changes you've made so far. Once the lock is freed, you want to produce a success response. Insert a set payload processor. Enter a meaningful display name. And enter an example JSON success response. Again, save the changes you've made so far. You have almost finished building the flow. All that's left is to properly control the exception that is thrown when the lock could not be acquired. So add a new catch exception strategy where you will build an error response JSON. Insert a set payload processor to set the exception cause description as the new payload. Modify the display name to something more meaningful. And as value enter the expression to extract the exception cause description. Now add an object to JSON transformer as it is the desired response type. Also, you want to inform about a server error by setting HTTP response status to 500. So add a property processor. Change its display name. Select Set Property Operation. Enter http.status as property name and 500 as property value. The flow is already built, but a final step remains to finish the example application. This connector supports multiple Apache Ignite versions, on this video's recording date, from 2.4 to 2.6. In order to fulfill this objective, you must be able to choose the libraries that are packed inside the application, so the Apache Ignite connector does not include them. It is your responsibility to add these dependencies. So go to the Global Elements tab and add a new Apache Ignite configuration element. Select the connection manager you built previously and add the 3 dependencies required, starting by Ignite core. The group is org.apache.ignite. The artifact is Ignite core. And enter 2.6.0 as version, although we could set any supported one. Now continue with Ignite indexing dependency. Same group. The artifact is Ignite indexing. And enter the same version you did before. Finally, configure Ignite SLF4J dependency. Press OK. And save the changes. We are done with flow building. Now run the example in order to check the 3 scenarios I mentioned at the beginning. At the Package Explorer, right-click with your mouse on the project and, at the contextual menu, select Run As and Mule Application. The application should start without any problem, so wait until the deploy message appears on the console. Here it is. I am going to use Postman application, although you could use SOAP UI, curl or just a web browser. Let's check the first scenario. We will acquire the lock while it is free, something we should always be able to do. Enter the inbound endpoint URL, that is HTTP, localhost, 8081 and run. In about 10 seconds you will get a success message. Like this. To check the second scenario, duplicate the tab in order to run 2 queries at a time. The first one will hold the lock for 10 seconds. If you are fast enough, the second one will fail after 5 seconds due to timeout to acquire the lock. So run the first query and quickly run the second one. The latter will fail after 5 seconds. And we check that the former ends with success. All fine so far. Finally, in the third scenario you will check that the flow halts and acquires the lock if, even though the lock is held by another process that releases it within 5 seconds. This is a little bit more difficult to test because we have to wait more than 5 seconds but less than 10 between the first and the second requests. So run the first request and count to 5. 1, 2, 3, 4, 5, and run the second request. Check that the former request ends with success. And check that the latter also ends with success in about 15 seconds after start. Perfect. And that concludes this example. If you want to download the full example, see the documentation or view other tutorials, we invite you to register at our website if you have not yet done so. Thanks and see you soon.